Good morning, friends. Welcome to the second edition of Elets Diagnostics Leadership Summit. This session will be on how automation is bringing rapid advances in genomics. And joining us in this panel discussion are Dr. Abhig Banerjee, Zonal Technical Chief, East Zone at Apollo Diagnostics. Dr. Banerjee will also be moderating this panel discussion. Next, I have Dr. Amrit Kaur Kalar, Professor of Pathology, TOMCH, Fellow Molecular Pathology and Cancer Genomics, Strand Life Sciences at at HCG Bangalore. Next, I have Dr. Anuradha Udmudi, Founder Director at Gene Tech Private Limited. Next, I have Dr. Jayalakshmi Jayarajan, Professor and HOD at KMCH Institute of Health Sciences and Research. And I also have Dr. Anita Shobha Flynn, consultant pathologist at Medal Clumex Diagnostics. Welcome, ladies and gentlemen, to this panel discussion. And now I would like to invite Dr. Banerjee to moderate this panel.
Thank you, Minmoy. Uh, Thanks to all the panel members and thanks to all the delegates for attending this session. I'm sure that this session is going to be very interesting and this will definitely make some changes in our clinical practice. So, the topic of this panel discussion is how automation is bringing rapid advances in genomics. So, as we all know, genomics refers to a field of study of whole genomes of organisms while incorporating elements from genetics and genomic study. So, DNA sequence analysis provides a very clearer understanding of how genetic variation leads to disease and it will ultimately lead to new cures. With the technological advancements and increasing computational capacities, there has been significant and robust improvement in knowledge of genome sequencing. Novel advances in medicine are being made at a rapidly increasing pace, largely due to the recent developments in genome analysis. Such advances in DNA sequencing technology have made it cost effective and more accessible than before, what we could not imagine earlier, which has led to a flurry of genetics testing startup. We have seen many labs now they are coming up with the genetic testing facilities. We have also seen more and more use of automation in genetic testing. Interestingly, the global lab automation in genomics is expected to grow at a CAGR of 2026. So definitely this is quite interesting and we will see many more changes in this field. With this context, through this panel discussion, we will try to explore the present, future, and its potential of automation in genomics. So, we have the respected panel members who are the giants in their own fields. Dr. Amrit Kaur Kaler, who is the professor of pathology, TOMCH, fellow molecular pathology and cancer genomics in Strand Life Science, HCG Bangalore. Dr. Anuradha Urumuri, founder director of Gentech Private Limited. Dr. Jayalakshmi Jayarajan, professor and HOD KMCH Institute of Health Science and Research. And we have also Dr. Anita Shobha Flynn, who is the senior consultant pathologist, Medall Cumex Diagnostics. So I will go to the questions, some questions which come to my mind, and definitely after these questions, if we will also take some questions from the audiences, and chat box is open. If the questions are there, we will definitely take some questions as per our time availability, and we'll ask our panelists to respond to those questions. So, my first question to Amrit Kaur, Madam, Dr. Amrit Kaur. Madam, what is the requirement of bringing automation in genomics? I mean, everything was going very fine. It is not that people were not doing genomics or genetic testing. In India, even there were some labs, definitely limited, but there were some labs. So they were doing many parts were semi-automated, many parts of manual. But what was the requirement of bringing this automation in genomics? If you can please explain. Madam, if you can just unmute, if you can unmute yourself. Dr. Amrit, if you can unmute. Yeah, we can hear you. Please. Yes, please.
All right. Oh, thank you. Thank you, Dr. Abhi, for the question. I think the automation in genomics has revolutionized in the present scenario. I mean, there was an unprecedented, the effect, or you can say the demand of COVID-19 testing in this present era, with so much of workload on the diagnostics for the testing results and everything. It was a really chaos of the in the present scenario. So what happened was that because of this situation, many of the industries, they came out with an automated system for the basic step of DNA extraction, which included a DNA and RNA extraction. So with the result, the handling of the specimens became easy. The workload became a little bit easier for the technicians and the diagnostic people to handle. Now, before I go in any further, that I would like to emphasize on two types of the systems, automated systems which were introduced, which are still prevalent in the present scenario. These are again standalone extractions, and then we have a large robotic handlers. In a standalone extractions, we deal with a low to moderate amount of samples, and in this, the DNA extraction is being carried out for different types of samples, example, infectious conditions. But if you are dealing with a large robotic specimens, they can be automated based on your requirement in the laboratory. So they will have a heating system, they will have a cleaning of the DNA extraction, plus they will have a little bit of shakers, which is known as a focus sonicators, which are available embedded into the system. So these are basically open systems, which are the robotic systems, which can be used and customized according to your own need. And then recently, the sequencers have come up, MISIC, which are being also used for the cancer genomics. And these are again, used for a small panels, which can be hereditary panels or a germline panels or a small target panels of 40 to 50 genes. So then the automated pipelines have come into, and it is helping us to understand the type of the variant which is present, and it's help us to sequence the type of gene which is present. And when we say the variant classification, there's one important term which is being used for sequencing, which is known as VAF, variant allelic frequency, which helps us to understand the amount of the positive genes which are infected. Because if it is affected, if it is more than 50%, it is called a germline, and if it is less than 50%, it is called somatic. And also in the infectious conditions, also the CT value, which the RT-PCR which gives, and which helps us to measure the amount of the virus in the blood. So I think with this, I can say that the robotics or even the automation has helped us to lessen the work and revolutionize the whole industry here in genomics. Thank you, Abhi.
Very important, actually, as Dr. Amrit said. This COVID 19 has changed the entire paradigm of the healthcare system, the delivery, not only in diagnostic but also in therapeutic. So, as she rightly mentioned, the workload in the laboratories are increasing. So, we have to cope up with that workload. So, maybe the automation is helping in faster turnaround time, lesser manual intervention, so that we can utilize our manpower into more supervisory areas, but the continuous, the monotonous areas, those works can be done by the robotic arms, as she rightly said, in a large volume laboratory. Because even we have seen in West Bengal National Institute of Biomedical Genetics, where NIBMG, which are doing many sequencing nowadays. Initially, they have very lesser load, but then it slowly, gradually increased because South African variant, UK variant, they came into picture, and they had to sequence. And one of my colleagues is there in that lab, so they were saying, okay, this kind of sequencer or automated extractors, they changed the entire ballgame. Actually, it's a different ballgame, and they have been able to cater to the needs of the sequencing. And nowadays we are hearing there are many other screens also coming up. So I am sure that this kind of automation will help us a lot to fight with the COVID-19 pandemic. Thank you, Dr. Anita, Dr. Amrit. My second question to Dr. Jayalakshmi, madam. What are the areas where automation is already placed in genomics? I mean, it is available, already available. That I would like to know. Dr. Jayalakshmi, if you can unmute, madam, please unmute.
Can you
Yes,
hear
madam.
me now?
Yes, yes, yes. Fine.
Yes.
Please continue.
Okay. So if you would, I would just take into continuation of what Ma'am was mentioning to us a little while back. Taking the same scenario of the pandemic and COVID, thanks to COVID, because we've got the technology in places all over the country now. It is reachable to all areas which were not accessible to great testing in the past, and where samples used to be sent across, now it's available in those areas. And automation has helped greatly. And earlier we used to look at automation more in laboratories in terms of biochemical parameters or hematology parameters, very challenging for the others earlier. But then genomics, where it is easy, where you can have the technology and also have the automation with advancements happening in genomics. This has been possible at almost all levels. If you would look at what we had in 1.5 years back when we started with the pandemic of COVID, and we wanted to test for the virus across, we're finding it so difficult because lesser laboratories and lesser facilities available for testing the same, and it was challenging for people to do also. But in the last 1.5 years, you would see that there's so much change, and thanks to this technology, and predominantly because of automation, robotics in place in major areas, being the key game changer. And they brought all the bigger laboratory systems into smaller mobile units, which can reach the concerned areas. Like for example, if there would be a need into a remote setting for surveillance or for testing, so it was easy to shift the entire system easily, and that was because of automation and thanks to that. And what had automated predominantly, because there were some struggle areas. If your extraction was not happening well, then the entire process would go waste. Okay, so sample collection was one challenging area, but the more challenging area once it reaches the lab is the extraction. If extraction has been bad, more so with this being an RNA virus, it was such a challenge for most of them. And so automation in automated extractors, it was unbelievable what was happening for hours had become in minutes, and it was all much more standardized. The way the results would be also was so very reproducible, excellent production. So extraction was one great area where it changed the whole scenario for almost all. Major laboratories also had taken into the next levels of processing, also even into adding of reagents, the liquid based systems, where your PCR processing also into add further into loading into your amplification devices, whatever they would have, also had made that big change. So from extraction to the final product being there, entire thing was automated for you to just get the report at a click of button after a period of time. So this was something that was wonderful to see with the infectious diseases. And time was drastically brought down, and technology, health, and automation in all of these areas where there is extraction, health, and then PCR amplification did help, and then also for the reporting as well. But if you would see other areas, there were these CRISPR-based fragment analysis systems which are fully automated. Then you would also have these, the next generation sequencing happening, where you would prepare this NGS library. So all of those were automated. Microarrays are automated. Gene expression analysis are automated, and they also have this RNA interference screening also, or RNAi as we would call. Those screenings have also been automated. So you have various ranges of automation all in one sequence. So there are, depending on the need of the laboratories, either one part of it has been adapted by the system, or entire sequence where you just walk away from, just load the sample and walk away. And that is an excellent thing that has happened with the technology. So that is wonderful. So thank you very much for that question.
Uh, so Dr. Jayalakshmi has nicely explained the things actually, both in not only in infectious but in oncology profiling, how the automation has really been able to improve the situation. And in this context, I would also like to add, however, this is not in India, but what thing happened in US in November 2009, Thermo Fisher Scientific, we all know the name of this company, announced its Ion Torrent Genexus system. Ion Torrent Genexus system. It is the first fully integrated next generation sequencing NGS platform featuring an automated specimen to report workflow. As Madam Dr. Jalashmi said, it's a complete solution from sample processing, sample receipt, specimen processing to report that delivers results economically in a single day. What we could not even think in a case of NGS, next generation sequencing, usually the reports take 10 days, 15 days, or even the 5 days, 6 days, at least for a week. But here it delivers the results economically in a single day due to automation. And this solution redefines the genomic profiling paradigm and enables a future in which even the local satellite labs or hospitals, they can adopt NGS testing. What was not previously done, NGS was always for the prime locations, metro cities, where we have seen corporate giants, the major players, they are only using the centralized ETOS. So decentralization could not happen in NGS. Even it is not in India till now. Usually in a chain, in my laboratory like Apollo Diagnostic or even all the other laboratories from you are coming, everyone, they have a centralized unit where all the samples were coming from sequencing or whatever. And this genomic sequencing or NGS was being used in a single laboratory. But here, this ion torrent Thermo Fisher scientific system has been able in US, at least in US. Definitely, they are economically stronger, but at least they have been able to bring a solution where NGS can be even brought to the doorstep of the remote areas. The local lab, satellite lab, they can also use, and this is thanks to automation. This is helping us a lot. So, with this, my third question actually to Dr. Anuradha, madam. What is madam is actually she's an expert in the clinical genomics area. She has a rich experience. What I came to know. So she's working basically in clinical genomics area. So I would like to understand the status of automation in genomics, but and related challenges specific to India, especially in areas of clinical genomics, challenges and the status of genomics in clinical genomics in India. Yes,
Oh,
ma'am.
thank you, Dr. Ravi. So before we get started, as Dr. Ravi was saying, I'm in the space of clinical genomics, mostly in the reproductive and developmental genomics. So my focus would be mostly on that area. But if you think about automation as such in this field of genomics, it's basically an outcome of worldwide efforts of labs to finish human genome project, and we all know about that. And the number of human genome sequence was somewhere in thousands a few years back and now have reached millions in 2020 itself. And to not to sound very pessimistic, but India's contribution to this number is very, very negligible. And we all need to understand where we stand today and what we need to do to increase our share in the global human genome sequences that we are depositing. There's no doubt that genomics has arrived to India, but to reach its potential, I think there's a lot desired to be accomplished here. Slowly and steadily, the area where we are in, the medical practice in India, is integrating genomics into its clinics and hospitals. Public awareness is also increasing quite a bit, and in this scenario, a majority of labs in India offering clinical genomics are now in this dilemma whether to automate their genomic lab or not. And I'm talking about all sizes of labs that are present in our country. And of course, not many, but whatever limited number are present. And if they want to automate, to what extent should this automation be? And what will be the cost benefit ratio for these laboratories? And that's the most important point that we need to consider in our country. Some may say workforce cost is not much in India, and therefore why do we automate at all? What is the need of doing automation in such a aggressive fashion? And if we want to, but as you all know, cost of employable workforce is increasing, and also you may want to consider, like one of the panelists was saying, to use their brain power where it is needed rather than making them do the routine bench work. Okay, and now we all know that errors on bench work during bench work is one of the things that we are all scared of, and we are trying to reduce. And also another point which I guess another panelist will take up in future is the attrition and training in the field that we will have to worry about if we are only concentrating on the workforce. So considering all these points, I think automation for your lab is not a bad idea, but and then of course there are few clinical genomic labs already started automating their workflows. In fact, COVID testing, as everyone is saying, has forced labs to take these steps in this direction. The basic task for Indian labs I feel, is to define their scale of automation and then plan accordingly. Now, when you think of your scale, you may want to break down the workflow into steps and then work on that specific step that you think automation would be best suited for your kind of throughput. And this is not something that is even for all laboratories. Every lab will have a different requirement. In my field, the clinical genomics turnaround time is the most important aspect, and therefore our automation processes are all revolving around turnaround time to offer report as quickly as possible. Now, why big deck liquid handling systems are available, you can just automate that and walk away from your NGS preparations, and with all the PCR included in the systems on board, and it increases. But the thing is, it increases your cost, and often this point is the roadblock. That fully automated lab is something that we are not aware of as this point completely in Indian laboratories. I think the initial cost of fully automated labs is very high, and not only that, labs will have to consider the components that will come, which are extremely expensive, and maintenance is an issue that we need to consider, whether the system is an open system or a closed system, what kind of labware is required. I'm talking this in very specific to Indian requirements, where we are not industrializing the processes yet. And clinical genomics is an area where a doctor is personally referring a case and you are giving a report to that specific doctor. And so these things, cost becomes very, very important. So based on your scale of operations, although some labs are into automation, I think Indian labs are good to have a semi-automated workflow for their system, for their labs. And this can be anything. You can have a robotic mechanism in place just for your gel casting, if you are into PCR, right? You can have a sample preparation kind of automation, if that's the bottleneck that you think. Some labs in India already have sequencing is anyway semi-automated, and it is, and therefore you need to integrate and think about what is the best suitable liquid handling system and the sequencing automation. Of course, you may also want to think about miniaturization. That is also another thing that is now available in the country, and some of us are already experimenting with miniaturization. This is a way of going forward to reduce cost for Indian labs and for Indian customers. Another area of Indian-based challenge is bioinformatics and data analysis. Again, here we need to do, although variant calling pipelines have a long way to go and are also developing day by day to minimize technical errors and to suit the exome capturing kits and things like that. But what is more important is to have a Indian database specific pipelines that would give us information about our population. And this is where I think we need to spend a lot of time on this aspect of automation. For example, we have done something in the area of infertility where we have analyzed the phenotype and genotype, and we have come up with around risk estimation for more than 300 fertility and pregnancy related risks for our population. And we do clinical recommendations based on that, also pharmacogenomic implications. So there are n number of areas for improvement of automation of genomics in our country. All in all, to summarize, the there are just 3 points that a lab should consider, whether small, average, or a big laboratory, is what is my choice of automation product suitable for my specific lab needs. Second, how do you address bioinformatics of your and data analysis issue, which is specific to your population? If you are in that space of looking at population variants, and of course, last but not least is return on investment. Would automation actually offer that? And I mean, if these three questions are answered, I think many labs in India can move towards semi-automated genomics laboratories. So, with that, I think I can, wrap up my answer.
No, no, Dr. Anuradha, it's really very interesting, and you elaborated almost all the points, and which what was important, and most probably all the audiences would like that here many are we, including us, we are there from the clinical laboratories, and we have seen a competitive market now. Everybody is doing sequencing, genomics, etc. And there have been I personally know some labs which started with a lot of capex, started their sequencing, seeing another corporate giant that they are also doing, so why I will not do. But then they suffered a lot because the capex or huge in there was a huge investment. There were consumables, the price of the consumables went high, but then there was no adequate number of samples, because you have to balance that cost benefit ratio also. How much will be your return of investment? Because ultimately we are all commercial labs, not I am
Sure.
not discussing about the research laboratories or the government funded organizations or NGO runs organizations. We are talking about the commercial labs, the clinical genomics part, where maximum laboratories are private, and they should understand this, that what will be, see, it is very easy to do a first time investment because loans are available, banks, financial organizations are there to give you huge investment. But whether that return of investment, because ultimately you have to serve the patients, and the purpose will be purpose maybe, I mean, maybe lost if you are not being able to get adequate number of samples. So
Yes.
that is a very
Yes.
important point. Thank you, madam, as for enlightening us. My next question to Dr. Anita Flynn, madam. uh, Madam is also working in a laboratory, so that is, I'll be interested to know that everyone, actually, even Dr. Anuradha touched a point. I understood that the automation is going on. There is many updated instruments, equipment, fully automated, semi-automated, but man behind the machine is important. We should always remember. So, madam, how you are dealing with this problem? Because there, with the advancement of technologies, we are bringing automation. How have you trained your technologies to remain up to date? Because ultimately, they will run the machine. You maybe at the pathologist seat, you will just sign out the report. Maybe sometimes you will supervise in a day or two, but they will be at bench level. Even if it is a walkaway system, you have to start the machine, you have to troubleshoot in case of any problem, initial troubleshooting. So how you have trained your technologies to remain up to date with more and more introduction of automation, that I will have to understand. Madam, if you can just unmute yourself, Dr. Anita, if you can unmute. Yeah, fine.
Thank you, Dr. Abhik, and it's an honor for me to be here with among my esteemed colleagues. And at this point, I would like to thank Elets also for me to speak at the summit. Coming to my question, coming to your question rather, how have I trained my technologists or my technicians to remain up to date with more and more automation in the lab? As we know, the healthcare and the diagnostic market is pushing labs to cut costs, maximize their revenues, and of course increase testing volumes. Not to forget, keeping up with the turnaround times. So the to address all these issues, automation in the labs is the answer, to which most lab managers are looking. And regarding our technicians, I think, if we look at it from their point of view also, I think one of the biggest fears that technicians have regarding automation is, the fear of losing their jobs. And so what the thing for, the way for people in charge of the lab, like lab directors, lab managers, is to convince the technologists to make them understand that even
with automation, we still need manpower to run them. See, at this time, I was just going through all these Elets journals, and I just came across one very good quote of one Dr. Anjali Tiwari, who's the lab director of Regency Hospitals in Kanpur. And Dr. Anuradha also just touched upon the same thing. She says, a totally automated, I'll just read it out here, a totally automated robotic lab will require least number of people and in turn displace skilled workers. We as a country cannot afford unemployment. Also, the cost of automation may not. Hence, we have to use AI as an assistive tool to make clinical decisions so that the systems become more effective. Now, the main task for lab managers here is, I feel, to make the technicians understand that automation is going to take care of, there are jobs, there are works in the lab which are repetitive, they are tedious, they are time consuming. And when humans are doing that, when technicians are doing that, there is a time when they get bored, they get tired, and then the efficiency comes down, and then of course it's a spiraling process. So if there is automation, it will take care of all these tedious jobs, repetitive jobs, and it'll free up time for the technician to learn new skills in the lab, or to update themselves with something new, or to involve them in something which is more constructive and more productive for the lab. Appropriate what I was just thinking about this whole thing, and I just noted down some points. And there are a few points that I would, as a former lab director, and I was a lab director in a hospital here for quite a few years. And what I would feel that, like, I would like to train my technicians in a couple of points. One is, the most important thing is to learn to troubleshoot the problem areas in automated systems. So to do that, they have to really become familiar with the machine. They have to become familiar with the software that is there in the machine, because problems can occur anytime in the working of these machines, and they must know how to troubleshoot. Then, secondly, is how to interpret quality control data. Now, the machines, we are running quality controls daily, or maybe on multiple times during the day. So they should know how to run the quality control. They should know how to interpret the data. Then, thirdly, they should have a quality assurance system in place, so that when they get the QC data, they should know that, okay, is this a correct thing or not? Should we take this forward? And also ensure quality test information. The other point is risk management techniques. They have to be aware of what are the risks associated with the machine, and they must know what is the corrective action, preventive action, all those things they have to know. Next point is interpretation of output data. Now, the machine, when we are automating our lab, we are increasing the testing volumes. When we increase the testing volumes, we have a huge amount of data that is being thrown out at us, and which we are, reporting, and we are giving out, generating to the patients. And this is something, I mean, they have to know when, which is the data that they can, directly send out for to the patients, or there are some, important, some difficult things are there, some tricky things are there, which they must bring to the attention of the pathologist, or the microbiologist, or the biochemist, whoever is running the show over there. Then the other thing is that they should be able to liaise with the vendors, the equipment vendors, and the service engineers. In doing so, they are going to get a better understanding of the systems, the automated systems, and they will also get exposed to, with their discussions, they will get exposed to other different kind of technologies that are out there in the field, and that they can, they may get exposed to in future. The next point I feel that lab managers should look also is that we should be training our technicians. Training is a very important part, training and educating them. So encourage them to go for CMEs, encourage them to go for workshops, so that they can improve their working knowledge. And last but not least, the trainee should become the trainer at some point. So that means that once the technician is well trained, and he is like fully hands on with the equipment, then he must take into this thing that the junior technicians who are coming in, the newly joined staff who are coming in, they must have regular training programs. The technicians then should assist in that. And this is of course something which one of the NABL clauses are also regarding this induction, and we should have the lab should have regular induction and orientation and training programs running throughout the year, wherein the technicians keep getting upgraded with whatever is happening in the lab, whatever existing systems we have in the lab. So finally, as lab managers, the onus also lies with us, that we should equip our technicians with this kind of knowledge so that they too can progress along with our labs. Thank you.
Uh, Excellent, madam. Excellent. Actually, the points you almost covered almost all the points. Actually, even as per ISO 15189 2012 guideline, they have categorically mentioned the requirement of technical induction, not only the HR induction but a technical induction. That is requirement just to be familiar with the laboratory environment, how the processes are going on, and competency evaluation. That is very important. When the trainee, when the trainee joins, the staff joins, the initial competency evaluation, and in the first year, after 6 months, another competency evaluation, and then if the staff continues, once in a year
Correct.
competency evaluation. That is very very required,
Yes.
and we have to understand that, and we all should, as lab director, lab managers, or the supervisory positions who are there, they should understand that ultimately these people are the most strength point of the lab. So if they are not up to date, the automation, even if we bring into our lab with a huge cost and investment, they will not be able to give the appropriate or result to us what we intend. So that is very fantastic. We are running little short of time, so but I have many questions to all of you. I will just now ask, request Dr. Amrit Kaur, just to give a few points, point wise, not taking much time. What have been the major advantages of automation in genomics?
See, Dr. Abhi, I work in a cancer genomics center. So I will just associate the whole scenario along with that. So we are dealing with the both solid and hematological malignancies. So in the hematological malignancies, we have like monitoring of the treatment of imatinib to the in the CML patients. So if the thermocycler is not automated, if the instrument is not automated, it's very difficult to handle the load of the patient sometimes, because we know that the dealing with the both the type of malignancies is at the same time it might be difficult. So if we have a EGFR mutation, example in the lung cancer, and the patient is adenocarcinoma, we have to look for all the 18 mutations in the EGFR gene, that if they are resistant or they are sensitive. So if they are sensitive, obviously we can give the first generation TKIs, and if it is T790M mutation is present, then obviously we have to go for third generation TKI. So similarly, the same workflow goes with all the other malignancies like the urothelial malignancies, and comprehensive gene analysis has been indicated in TNBCs, lung cancers, urothelial cancers, and even in GIT cancers. In GIT also, the BRAF, KRAS, NRAS is a reflex testing, which is indicated in all the type of cancers. And also PDL1 and TMB has come up recently, and these are the genomic markers for immunotherapy. So that is why, the availability of this test and the automation is necessary for the shorter turnaround time and a higher reproducibility, because uh, there is a less chances of contamination. The most important step is the DNA extraction and sometimes the cDNA extraction. So if that part is taken care, then obviously there's a high throughput. You can take more samples and you can shorten the turnaround times. And now recently, because of the comprehensive gene analysis, so many genes are, we get to see on daily basis, even though they are being indicated in the advanced or the metastatic diseases, we are able to see in the first line at the time of diagnosis. So if we are able to target them at that particular point, example, c-kit is present in lots of diseases, and there are so many other genes, STHA, B. So if we are able to rule out all the syndromes which are present, like HBOC, hereditary breast and ovarian cancers, I mean, because the PARP inhibitors, which are recently being used to inhibit these cancers, it will make our work a lot more easier. for treating these patients. So, and just want to summarize that these treatments are effective, they are helping the patient, and we are picking up it in India. So it's best that we automize all the instruments and make this treatment available for all our cancer patients. I think because of the less time, I think I'll
Thank you.
just
Yeah, yeah.
round
No,
up
no, no.
at this
I
situation.
understand.
Thank you.
No, thank you, Dr. Amrit. And what actually Dr. Amrit wanted to highlight, I think, the era of precision medicine, targeted therapy
Yeah, I
for
just want to add one
signature
more
diagnosed.
thing,
Yes, yes, yes,
because
yes, yes.
all of the molecular markers, they are they have three uses. One is a diagnostic, prognostic, and predictive markers. So many of the cancers, they are being used for a diagnostic. Example, synovial carcinoma, it's all confusing with the spindle cell carcinomas. So the fish is mandatory in those cases. And sometimes the prognostic markers, KRAS is an oncogene, it is a driver mutation. No matter what all treatment you will give, it will definitely leads to a poor prognosis. And then obviously the predictive treatments which are available, and this has really helped the patient in advanced cases. And
Yeah,
thank
yeah.
you so much.
So that's why actually we are going to an era from morphology to molecular pathology.
Yes,
Previously, it
yes.
was actually dependent entirely on histopathology, morphological diagnostic. I am not saying that histopathology has been replaced, but histopathology will remain as it is. But morphology to molecular pathology, that means the molecular pathology will take a great role as an adjunct to morphology, and it will help the targeted therapy and precision medicine of the patient. So both will run simultaneously. Thank you. Dr. Anita, I have another question for you. In short, definitely, because we are running a little short of time. How
Yeah.
genomics is being used in improving public health?
Yeah, thank you. Thank you for the question. Now, ever since the COVID pandemic began, genomics has taken a center stage, so to say, in clinical and public health research. And it's a valuable tool in the prevention and control of both communicable as well as non communicable diseases. Public health genomics assesses basically the impact of genes and their interaction with behavior, diet, environment, with the population health. So, what basically it says, what is the promise of public health genomics? It is basically that practitioners and researchers data on relationships, between genetic traits and diseases across various populations should be presented, and to use this information to develop strategies to promote health, and also to prevent disease in populations, uh, and last but not least, to precisely target and evaluate the population based interventions. So basically, what is happening is that we have, at both individual levels as well as population levels, genomics is playing an important role in the management of controlling the understanding the infections and other diseases, non communicable also, and also preventing them. Now, for example, now whole genome sequencing has become the standard assay for characterizing infectious diseases. It's a rich source of information to guide public health interventions. For example, we have pathogen genomics, which is now being used to evaluate and to investigate foodborne diseases or hospital outbreaks, and also it is being incorporated into surveillance of clinically important features like vaccine antigens, and you have this antimicrobial resistance determinants. So it plays an important role in these things also. DNA sequencing can increase the precision of diagnosis beyond the species level to the identification of lineages and variants. For example, now in COVID, we are seeing all the emergence of the Delta variant and the Delta plus variants. So these variants, these may be associated with different degrees of risk, and thus prompt different responses in terms of clinical management or public health management, where we might need some infection control or contact tracing may be needed. The COVID-19 pandemic stimulated methods for rapid pathogen sequencing, for example, like the corona hit method for SARS-CoV-2. And this is one way how real time pathogen data was used to form public health strategy in the context of an ongoing pandemic. CoronaHit is a platform and a throughput flexible method for sequencing the SARS-CoV-2 genome. Again, it's an automated method that can multiplex up to 94 genomes per nanopore flow cell. This method does not compromise the quality of genome and also reduces the library preparation complexity and significantly reduces the cost. Again, this has aided the rapid expansion of the SARS-CoV-2 genome sequencing throughout the world to control the pandemic. There are some challenges that are associated with generating and sharing sequencing data in a timely, equitable, and ethical manner. And then there are challenges that are there with data visualization, genetic variants, and communicating results to the public health sector as well as the public. And these are some things that need to be looked into. But I think, as more and more labs are being, they are mushrooming, and molecular diagnosis labs, and they are being many labs are being converted into molecular testing labs, and a lot of labs are taking up genomics now with automated systems. I think this is the future that we are looking at in public health. Thank you.
Thank you, Dr. Anita. Yeah, yeah. So that is very an important review what Madam has given us. My next question to Dr. Jayalakshmi. Again, that same because I'm not me only. Everybody is concerned about the genomics in India because we are ultimately living in a country which is still we cannot compare economically with US or UK or even China. So, in that case, can you justify the cost impact of bringing automation in India against the benefits it may provide? The benefits we have seen, many benefits. There is increased productivity, as Dr. Aditya said, less chance of cross contamination, everything, faster turnaround time. But there is a cost impact. I think Dr. Jayalakshmi has said that there is a huge cost impact in view of capex, the initial investment, as well as the consumer. So, how you balance, madam? What is your advice to the
Yeah,
laboratory
thank you very
practitioners?
much. Yeah, cost is definitely an important factor, particularly in a country like ours. However, it is the initial cost that is going to be very much that the lab has to handle. However, the recurring cost may not be as high when you choose your automation well, right? It depends on the type of technology that you use and the need for the system also. So usually the initial cost may be slightly higher, but the recurring may be not so. However, it could be compensated by having lesser number of manpower instead of having too many skilled personnels. You may not be finding them adequate enough. Also, having skilled personnels in numbers more is equally challenging. So, therefore, your the personal requirements in when you have your automations in place is definitely lesser. You only require them to probably man the system or monitor the systems or just load and unload the samples, etc. So it may be very less. So there are studies which said that about if you were to require, if a lab would require about 6 to 8% of skilled personnel in particular lab, they have found to be working efficiently well with 2 to 3% in the same laboratories with automation when they had their extractors in place and then with their amplification devices were automated, etc. So this has definitely lessens the cost, right? Right, it definitely reduces, and then it definitely is error. It like all other speakers have already mentioned. It definitely reduces the manual errors or the operator errors, as we would say, and there is no you don't have to repeat it again. And reproducibility is excellent with these automated systems. It definitely it becomes more reliable. Your reports are much more reliable. But what is more advantageous is the time. The time taken in an automated system is definitely much lesser than what it would, particularly when I would say in terms where in identifying an infectious diseases, that as I would say, even in terms of identifying COVID-19. So what would take about 6 to 8 hours in a routine laboratory has now become 1 to 2 hours. So in 1 to 2 hours, you're able to give a report, and the clinician receives the report much early. He starts therapy on the patient much early. The clinical outcomes on these patients are much better, and you are reducing the transmission of these infectious diseases largely also within families or communities. So there is a better management, maybe identifying malignancies or metabolic disorders or infectious diseases. Early diagnosis is something that can make a big change in the management and outcomes and the the morbidity mortality of these patients, which is what is the most important thing that we would look for. So,
Yeah.
and since there are larger numbers of samples that can be tested also, the turnaround time is good, the throughput is good, the cost, maybe the equipment cost may be initially there, but however you are reducing on various other things in the future, it gets standardized. It gets much more standardized, and the way that you interpret the report and the reporting format also gets standardized. Somebody is at the satellite access center not required to be there or always there, because on the same panel that they can see exactly what is seen in the laboratory on the system. So you can have a share where you will be able to see exactly what you're seeing, and it can be automated and reported as well. So all of these can definitely have a greater benefit for the patient as a person, and for the clinician who's looking out for these tests, and also as a community when you're trying to screen out for larger numbers of tests. So automation, though it looks as if it is costly, definitely not so. When you look at the benefits, definitely the benefits outweigh the cost. Thank you very much.
Thank you, Dr. Rashmi. It's a fantastic overview and outlook. Though I should finish the session because we have to take some questions from the audience, and we have questions from audience I can see. But before that, this session will not be complete unless we try to summarize, because we have seen many aspects of the automation. All the panel members have given their inputs. So my last question to Dr. Anuradha, if she can just summarize the thing, how do you see the overall future of automation in genomics? The future of automation in India or whatever, what are the upcoming things, and ultimately whether automation will be in place or not in place as per our expectation because of the cost or whatever, manpower, training, etc. So in 2 or 3 lines, madam, if you can just summarize the thing, future of automation.
Ma'am, you're muted. Dr.
Madam, if you
Anuradha,
can unmute. If you can unmute, madam. Unmute.
Sorry about that. Can you hear me now? Yeah. So automation will be in place, and that's the way forward. And with integration of miniaturization and microfluidics, I think the logical future of genomics is going to be lab on chip. In what scale, I'm not sure at this point of time, and how much of it in India, but that's where the logical future would land. There will be development of biochips with applications that are unlimited in SNP analysis, gene expression studies, disease classification, or you may call functional studies, drug development, clinical diagnostics, but the applications on biochips would be high, and I'm sure there will be a lot of automation that we are going to see on RNA sequencing and protein chips that will be developed in future, because that's where we need to get the clinical correlation, a much more clinical correlation than just the genomic DNA, right? And attempts to reduce the size of the microarray spots and things like that has been going on for 2-3 decades. And I mean, the goal is to get single molecule into one array, which means the single genomics applications will increase, and we will see a lot of automation in that direction. We need to look at high mobility of testing in sense of infectious diseases and other things. You may want to take the lab to the patients or to the population rather than them coming and giving us the samples. So the real-time processing automation is one another thing that will be there. I also visualize CRISPR-based automation too, and this is where I always wonder whether we'll just read the genome or will we write it in future. We do not know, but automation is definitely going to help us do both these. Epigenetics related automation is going to increase, and we will have to watch out for that space, especially in the view of population genetics. Metagenetics related automation will increase. So all in all, innovation in automation of genomics is a great opportunity for us, for startups in India. and we should be building automation tools that are suitable for our country at an economical price, and everybody can't be doing everything. So therefore high throughput sequencing service providers may also emerge. That's my logical thing with, so people can be, some could be concentrating on bioinformatic companies. They may develop powerful data analysis tools, clinical interpretation related tools, and automation for data security tools will increase in future. So what we are looking at is the country like ours to address resources, funding, public-private partnership in this area to enable automation in genomics, to make us reach the goal and be on par with other countries and other laboratories worldwide.
Thank you.
Thank you.
Thank you, Doctor. It's very nice. So we do not have time, but I have many questions in my mind which are roaming about. So now, when we are already submerged into the ocean of knowledge and keen to know more and more from our panelists, the clock reminds us that the time is limited. Hence, I would come to the next very important part, without which this session remains incomplete. Yes, I'm talking about the question from house. I can see there are questions definitely from audiences, but I'm sorry we can't take many questions now. What we can do that, we have our elect representative who can note down, jot down the questions, and they can the questions can be later on shared with me and the other panel members so that we can reply to them and they can send it to the as auditors. But one thing, just for 1 minute, if any one of you can respond. One question is there from the audience that point of care. Anything is there as a point of care instrument for in as automation in genomics, point of care instrument, so that we can reach the bedside, not in the lab, but point of care. Any idea about? So I think actually no such things exist now. But yes, some taste like Abbott, and some
Yeah.
companies like Philips, they have come up with some point of care machines, very small machines. They can be able, they can reach the oncology patients, but I mean cancer patients at bedside. Some of the tests can be done, but I'm not sure about the. They are FDA approved also, but we are not sure about the reliability of the precision, because anyway, for any point of care instrument, we have to ultimately keep it under supervision of the central laboratory, because the control calibrators and those things are very much important how we are running, because here we cannot take any chance. Any positive report, that means a significant therapeutic decision. Anyway, thank you. So now we are going to the concluding session. After getting very much good inputs from the all the panelists, what I can understand, I have jotted down some points that laboratory automation in genomics has proved to make room for greater flexibility, higher throughputs, and affordable solution. It offers faster handling, and process can be expedited without the worry for lack of reliability and precision. Genotyping and DNA sequencing have now been very affordable than previous era, due to which the rate of growth is robust. However, at the same time, India is a very large market with a population from varied socioeconomic status. Health insurance does not cover diagnostics yet in India, but disease burden is increasing, especially the oncology market. Hence, government and process owners, as Madam said, including lab management, corporate giants, manufacturers, should not overburden the customers with their cost of instrument for automation. They can increase the automation, but that the cost should not be shared with the customers and the end users. Given this context, there will be a greater focus on cost optimization across the value chain to keep bringing down the overall cost of delivery and making genomics diagnostic more affordable, and it should reach to all population, all socioeconomic strata of India. That is our aim, and not only a limited population we do not want to serve. Achieving lower total system cost but maintaining benefits of automation will clearly be the major challenge. As Dr. Anuradha and Dr. Jayalakshmi said, hence there will be a need for greater collaboration between instrument reagent manufacturers, service providers, including diagnostics and hospital facility operators, to eliminate non-value adding activities in value chain. Another key factor in helping bring down the cost will be around Make in India theme, what I think, because now the government is in giving importance to Make in India theme. Local manufacturing should see an increasing trend over the medium term, and this can help drive input cost down, because otherwise we have to import everything. That will increase the cost. So I hope the audience and delegates present here today is more than satisfied after this journey through the essence of automation in genomics. I'm sure that the rich experience that all of us gathered here is surely going to make difference in our clinical practice and understanding of current scenario of Indian genomic industry. I am really thankful to all of the panel members who have been there to spare their valuable moments. And I really thank the Elets representative, Mr. Minmoy Bhattacharya, Ms. Nehal, and all the other team members who have invited us and has this important session. I went through their brochure. All the sessions are very, very interesting. Due to lack of time, I could not attend them. But this genomics and this automation, this really are very well thought. And I thank the management of Elets for bringing up this session. I hand over to Mr. Minmoy Bhattacharya to conclude the session finally. Thank you. Thank you.
Thank you,
Thank you.
Dr. Banerjee, for a wonderful panel moderation, and thank you to all panelists for sharing their expert views and observations. As a token of our appreciation to you, would like to present certificates. Can you have the certificates on screen, please? Thank you, Dr. Abhik Banerjee, for moderating this panel.
Thank you. Thank you, Mr. Minmoy.
Thank you,
Thank
Dr.
you.
Amrit Kaur Kaler, for participating in this panel discussion. Thank you, Dr. Anuradha Udumodi, for participating in this panel discussion.
Thank you.
Thank you so much, Dr. Jayalakshmi Jayarajan, for participating in this panel discussion,
Thank you.
and Dr. Anita Shobha Flynn for participating in this panel discussion. Thank you so
Thank you.
much, and stay safe. Next session begins at 11:40. Thank you.
Thank you.
Thank you.
Thank
Thank
you
you
so
all.
much.
Thank you.